Now, there are only a few atoms that have a stable arrangement by themselves. Those are called the noble gases: helium, neon, and so on. All the other atoms must link up with other atoms and rearrange their electrons in some way to form a stable arrangement. And that's what drives chemistry. But this lesson needs to begin with us introducing to you the atoms. And to do this, we've added some class to this presentation. I've asked a good friend and colleague, Doug Van Hofwagen, that's an old friend, Doug Vander Griend, who will come out here in just a minute. Sorry, Doug. I'll buy you lunch. He will come in and he is going to sing a song. And while he's doing it, I will be working on this easel and painting or illustrating the song. In the true spirit of liberal arts, we got music and art with the science. Here we go. All right, we ready?
I'm ready. You weren't kidding about this crowd being intimidating.
Yeah.
This is bigger than the classes I teach, too.
Yeah.
So, music and chemistry have something in common. They both start with building blocks. When you sit down at a piano, you've got 88 different notes, which become the building blocks for any song you might use from there. I'm going to sing a song about the elements, the building blocks in chemistry. It was written by Tom Lehrer back in the 1950s. And I want to play it for you. And then, Larry, you're gonna write down.
I'll try to keep up.
You're going to write down the elements as I get through them?
Well, I think so.
Okay.
It's here. You notice that I have numbers in here. I'm not as sophisticated. I got to paint by numbers. But
Okay.
We'll go.
Okay. All right. So, you ready?
I'm ready.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, uridium, and strontium, and silicon, and silver, and samarium, and bismuth, rhodium, lithium, beryllium, and barium. How you doing there, Larry? You keeping up?
I'm working on it. It's a little tough. I'll resupply my paintbrush up.
Want me to slow down?
Well, yeah, maybe one element per minute might be good.
There is holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercury, molybdenum, and magnesium, dysprosium, and scandium, and cerium, and cesium, lead, praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium. Finally, there's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and carbon, chlorine, cobalt, copper, tungsten, and sodium. These are the only ones of which the news has come to Calvin. All 102 that have been found by 1957. Thank you.
Excellent, Doug. How do you like? Why don't you come around here?
Did you get all those?
How do you like my? I think I did. How do you like my masterpiece?
No. I had 102 in there. I don't see any of them.
But they're there. They're there. I'm sure. I just have to put the finishing touches on this.
Oh.
There we go.
Very nice. You were listening closely after all.
Look at that.
What is that?
Those are flowers. You know, when you sing at the end, you get flowers.
For me?
Yeah, they're for you. Isn't that nice?
Thank you very much.
Yeah, you're welcome.